Hi team, this is a quick rundown on the project that we have completed. It explains the designs. The first one, the design decision was taken to use the EnvoyProxy. It's being used by Google, Microsoft and all the big principals, Netflix. All the Google search that you're doing, it passes through the EnvoyProxy instance. So we were inspired by it and thought to use the same technology. This is the design we came up with. Basically, as you can notice, API gateway as always is in the front to face all the public traffic, and then inside we have all the microservices architecture that I'll be explaining, and in the front you have a client application. I have a short demo also on how the authentication is getting terminated at the API EnvoyProxy gateway level. That's the most important use case, because what happens at the API gateway level, it basically is the authentication termination point where the authentication completes here and then unauthenticated traffic goes inside, so that it can deal with all the authentication level issues. Similar TLS termination point, it can talk on the TLS 1.2, 1.3, but inside it's an unencrypted traffic because distributed logging is going on and so many other things. So really TLS overhead is not needed just to log a single maybe log entry. So it's optimal to use because it's a restricted LAN always, so you can terminate it here. And then you have protocol termination point also. EnvoyProxy is built up from the scratch. It's level 2, 3, 4 layers. It can all deal with the network traffic at those layers. So any client app that can talk in HTTP 2, or maybe it wants to opt for HTTP 3, it will talk to the EnvoyProxy in that protocol. It will upgrade that protocol. However, at the back end you might be having some old microservices, maybe you have PHP, maybe you have other languages that cannot talk on the latest protocol. So EnvoyProxy helps you there also. At the upstream you can configure which protocol maximum level you want or backward compatibility you want. So that is another beauty that you get from the EnvoyProxy. Another is aggregation. Basically aggregation is how basically what happens in the microservices is, suppose you want to do one transaction from the client app, you really do not need to raise multiple requests to different microservices. You just have to contact this guy, which is API gateway, and it can then do multiple requests on different microservices. It can aggregate the response. There is some logic involved. There are two ways to do that in normally API gateways. One is a Lua filter, which is a very famous language. However, EnvoyProxy doesn't recommend that because it's not a very performant code. Since EnvoyProxy already is a C++ based, it's a bit longer development route, but it's very fast. So you do all your aggregation here. The benefit is, suppose a request goes to multiple microservices and it comes back with a JSON response, and the JSON can be cached for like 1 minute. So this API gateway layer, it will send the response to the client and it will cache also using the cache filter, which is already enabled. And then further on, if the client comes back again within that cache time period, the request will be entertained from the EnvoyProxy level itself. It will not go inside and affect any of the internal microservices. This is very important and significant. Now coming back to the authentication delegation, what happens normally is you take the token. Here in example, in the demo that I'll be showing now, we are taking that token from the Firebase. Firebase gives the token directly to the client app without any involvement from the backend. You take the ticket from your identity provider. It can be Auth0, it can be Okta, it can be Google OIDC. All those things are also supported. But here we have a simpler one, Firebase. This token is then, after the login, is presented to the API EnvoyProxy gateway, and then using the authorization header, the bearer token is presented. EnvoyProxy then deals with all the authentication checks. It's sort of like pre-authentication that it does for you. So you have a principle of separation of concerns. So all the security and all type of authentication level attacks, EnvoyProxy is there to deal with you. It can even tell you in the logging that who is trying to hit your API with that many requests. Normally when you run the big web service on a public endpoint, such features are very, very important, because then you are able to figure out if it's an attack or not. Normally without such solutions you cannot even. So further to that, once you get the pre-authentication, inside if you notice JWT, you may forward to the internal microservice, but that's totally optional. I mean, you may not even forward it. It's an unauthenticated request. I mean, it does not make sense a transaction going on inside and it have to get authenticated across multiple microservices. That is definitely already a weak solution. Authentication happening again and again. It should only happen once. The GWT token here is forwarded only for the fact that you might need to fetch some claims like what email ID of the user was, and maybe which groups that user belonged to, or if was it an anonymous user. So those claims can be fetched only, but authentication is not there. If you do not do this at the API gateway level, then you end up doing the authentication at almost all of the microservices. Now these microservices, some of those can be in .NET, some can be in PHP, and those at different layers. Then it becomes very costly, and that becomes a weak chain in the link also. It becomes a reason for many exploits and vulnerabilities, because what happens is when multiple microservices are doing that thing, then there is a possibility that someone might know that this particular request does hell lot of authentication inside, and it can be misused and bombarded to bring the service or deteriorate the service quality at the minimum, which is why all the big principles go for a solution where you delegate your authentication at the API gateway level, where it can deal with all those things. So I'll be just now showing quickly the demo of how EnvoyProxy deal with these requests. Okay, for the demo I have one normal API, which is example API, accessible from everywhere. So here I invoke the API. It's accessible across the board. I will be using this as a microservice as an example just to showcase the example. And here I have two routes configured through my EnvoyProxy. One is test, for example, and this EnvoyProxy, the test route is doing no authentication, but directly just providing the service from the microservice. So this is one example. So you get the same response through the EnvoyProxy now, but here we have a special route also, which is called API/PAST, and for that we have mentioned that to use Firebase authentication. Means you do the authentication at the EnvoyProxy level, but at the back end there is no authentication, because as I said, it's a public API. So I'll be using that endpoint now, and I'll be hitting that request, and you see, since the token is already present there, it was not refreshed, it was old token. So it's immediately EnvoyProxy itself is detecting that JWT is expired, so it can deal with all those sorts of protections. Once the request is legit, only then it will allow it. For example, now this is for example my test APIs, a way to fetch the token from the Firebase. Now for example, I just issued a new fresh token and it expires, maybe it has some time, and now for example I just use this token from which is returned from the Firebase, and I replace the old token with a newly received token. It did not copy properly. At the same time, why not try some wrong values to see how it works. See, it's again detecting this some abnormality. So let us get the token again. Here we have it. I'll just copy it, and here I will now paste a proper token. Still not there. Yeah, at last the copy paste is done. And now once we send the proper token, and you see here we have the response, this authentication is successful. So from the client to the EnvoyProxy, we are done through the authentication, and in fact to the upstream you may choose to forward this JWT token or not, but main authentication is done by EnvoyProxy from the Firebase on your behalf, and the request is now legit request. It's something that can go in. It has a proper valid token from the Firebase. So this is how we have implemented our overall design. Just before conclusion, a short note on rest of the microservices. Here we have 4 or 5 microservices, mostly are using different stores. Like for example, this one is based on Redis cache, this one is primarily based on MongoDB, because MongoDB it can live with a huge amount of ingestion workload. It doesn't have to stick to the schemas and all those things, so there is no overhead, so it's pretty fast in that thing. And then we have the event bus and the Rabbit and MQ to coordinate with between the services. This is just for the replication mostly, and between the microservices we do not really have a chatter, most of the microservices they only talk to each other through the API gateway, as I said, at the aggregation layer. Otherwise, because as the principle of microservices, there is too much chatter between the two microservices. That's a bad design, because then that defeats the purpose. So each microservice should ideally be led by a different department, and ideally should have also its own unique data store with a different format of data, maybe the same data. So that's about it. We have other filters also, like for example, we have distributed logging. All the logs, we have Serilog sync to Elastic. All the logs from the distributed logging architecture, all containers are sending logs to our Elastic and Kibana. Our Envoy also sending to the same, and we have this Kubernetes farm. Basically all the containers are there for the immense scalability of the services. And then we have circuit breaking also. Anytime microservices are down, or we are maintaining, or we are developing new features, anything goes wrong, this EnvoyProxy is already a out of process proxy, which means it's already running as a separate container instance or somewhere separate to this primary infrastructure, which means you could do circuit breaking also. You can land the traffic to the maintenance page telling that our services are currently down, or we want to do this, or you may have high availability backup infrastructure where EnvoyProxy can conditionally ship the traffic to. So this about it. Thank you.